pyridazine. Pyridazine. So 6-membered unsaturated 2 nitrogen atoms at 1,2 position is called pyridazine. Now synthesis of this pyridazine from 1,4-diketones. From 1,4-diketones. When 1,4-diketones react with hydrogen upon heating to evaluate 2 moles of water molecule, then produces unsaturated compound. Saturated compound. When the saturated compound upon undergo reaction in presence of air, then cyclization, then produces pyridazine is the product. Dihydro derivative. This is dihydro derivative. When we, if we take second synthesis from gamma keto carboxylic acid, then that is uh, gamma dicarboxylic acid or gamma keto carboxylic acid. Then we take this dicarboxylic acid compound reacting with hydrogen involves in loss of 2 moles of water molecule. Then the product is NH, C double bond O, N, COH is the product. Okay. This is gamma keto carboxylic acid. Alpha, beta, gamma keto carboxylic acid. This is a carboxylic acid. When here this carboxylic acid, it is upon heating undergo decarboxylation. It is reacting with POCl3. In presence of palladium, carbon, hydrogen, in presence of air, they produces pyridazine is the product. Formation takes place. Next one is third synthesis. 1,2 this is 1,2,4,5 tetragen. 1,2,4,5 tetragen. When this 1,2,4,5 tetragen reacting with alkene undergo Diels-Alder reaction. Then the product is nitrogen and nitrogen, here R, 2 methyls. When it is involves upon heating by loss of nitrogen gas, then the product is pyridazine product will be formation takes place. Pyridazine product will be formation takes place. So these are the synthetic methods for the synthesis of pyridazine. Next, properties. Pyridines are weak base. They form salts with mineral acids. Protonation of secondary nitrogen is difficult because of the high energy required to generate two positive charges adjacent atoms. So uh, pyridine is act as a weak base. So in this pyridine, one of the nitrogen undergo protonation takes place. Second nitrogen protonation is highly difficult because two nitrogens on positive charge at adjacent position is very difficult. Therefore, this parent only one of the nitrogen undergo protonation takes place when reacting with alkyl halide. One of the nitrogen undergo protonation when reacting with hydrogen peroxide. When reacting with HCl, this is a derivative formation takes place. Electrophilic substitution reaction. Electrophilic substitution reactions. However, in pyridines are highly resistant towards electrophilic substitution reactions. No nitration, no sulfonation has been reported. Nitration takes place only when electron releasing groups are present on the ring. Okay, so this is here electrophilic substitution reactions. Electrophilic substitution reactions. In these electrophilic substitution reactions, highly resistant to electrophilic substitution reactions because of two nitrogen atoms are there. So therefore, their electron deficiency is there. Therefore, the electrophilic substitution reaction not possible. When electron releasing groups are present on pyridine ring, the electrophilic substitution reactions takes place. However, 4-nitropyridine is obtained indirectly through the nitration of pyridine N oxide followed by deoxygenation. Okay, that means electrophilic substitution. Nitration sulfonations are very difficult, but nitropyridine is obtained when this pyridine first undergo reacting with hydrogen peroxide. N oxide will be formation takes place. N oxide will be formation takes place. Then this N oxide undergo nitration with HNO3, H2SO4, HNO3, H2SO4, then produces nitration takes place, then followed by reacting with PCl3. This N oxide is converted into pyridine. So this indirectly we are producing nitropyridine. Reaction with nucleophilic substitution reactions. Nucleophilic substitution reactions. Nucleophilic substitution reactions. Nucleophilic substitution reactions. Nucleophilic substitution reactions at C3 position. Nucleophilic substitution reactions at C3 position. That is 1, 2, 3. This position undergo nucleophilic substitution reaction when reacting with the sodamide in presence of liquid ammonia. Chichibabin reaction. Chichibabin reaction. Amination takes place at third position. Chichibabin reaction. This is Chichibabin reaction. Best one is nucleophilic substitution reaction. Chichibabin reaction at C3 position will be takes place. Nucleophilic displacement reaction. Nucleophilic displacement reaction. Halopyridines undergo nucleophilic displacement reaction readily with the amines, alkoxides, alkethioamines. Halopyridines readily undergo nucleophilic displacement reaction. It is reacting with ammonia, then NH2. When reacting with alkoxide, O minus, When it is reacting with thioalkoxide, this product will be formation takes place. Next, photochemical reaction. When substituted pyridazine undergo Diels-Order reaction, undergo cycloaddition reaction, then produces this compound is similar to when it is involves in ring opening reaction. It is involves in ring opening reaction, then produces pyrazine 2,5-dimethyl pyrazine is the product will be formation takes place. This is a pyrazine. Next one is pyrimidine. When pyrimidine, two nitrogen atoms at 1,3 position, synthesis of this pyrimidine is, first method is from 1,3 diketones. These 1,3 diketones reacting with thiourea involves in loss of 2 moles of water molecule. Here hydrogen is that this hydrogen undergo displacement, shifting on sulfur atom. Therefore, the product will be formation takes place. Second method is from ketone and formamide. Second method is from ketone and formamide. From ketone and formamide. Ketone and formamide. Upon heating, we are getting pyrimidine is the product. So mechanism, when base reacting with here, abstract the proton from alpha position of ketone, then it is reacting with formamide, nucleophile attack at amide carbonyl, then pi bond shifting towards oxygen side, here OH, NH2. When it is involves in loss of water molecule, upon heating, loss of water molecule, then the product is phenyl C double bond O, double bond NH2. Again reacting it with another mole of formamide, then produces pyrimidine is the product. Pyrimidine is the product will be formation takes place. Next, 1,3-diketones. 1,3-diketones reacting with 2 moles of ammonia, then aldehyde, then produces pyrimidine is the product. Or this hydrogen, it is involved in loss of dehydrogenation. Then the product is pyrimidine will be formation takes place. Next reactions. Pyrimidines are weak base and can protonation by acids. Diprotonation takes place with strong acids. Electrophilic substitution reactions. Electrophilic substitution reactions takes place at electrophilic substitution reaction takes place. Electrophilic substitution reaction takes place at C5 position. Electrophilic substitution reactions takes place. Electrophilic substitution reactions takes place at C5 position. Though now pyrimidine reacting with bromine in presence of 130 degrees. Then the product is and is reacting with sulfonation, fuming H2SO4. SO3H will be formation takes place. Next, nucleophilic displacement reactions. nucleophilic displacement reaction, halogenate nucleophilic displacement reaction, halogenate 2 or 4 or 6th positions. Halogenate 2 or 4 or 6 position readily undergo nucleophilic displacement reaction. Halogenate 2, 4, 6 positions, 2, 4, 6 positions uh, readily undergo nucleophilic displacement reactions. The order of reactivity is halogenate 4th more reactive, then 6, 2 more reactive, 6 is more reactive. Like this is the order. When halogenate second position, it is reacting with sodium methoxide. So methoxide nucleophile displaces the chlorine nucleophile and reacting with the sodium alkoxide. That alkoxide displaces the group. So like this nucleophilic displacement reactions are takes place. Nucleophilic reagents reacting with nucleophilic reagents, reacting with the reaction with the nucleophilic agents, reaction with nucleophilic agents when pyrimidine reacting with hydrogen, at 130 degrees, undergo nucleophilic addition takes place. This one is undergo electrocyclic ring opening takes place. Electrocyclic ring opening will be takes place. Then the product is now it is involves in attack it here the pi bond shifting to nitrogen side. Then the product is NH, double bond, NH, NH. It is involves in hydrogen. The product is pyrozole will be formation takes place. Next one is reaction with important. This one reaction with Grignard reagent. RMGX Grignard reagent when it is involves in nucleophilic addition. RMGX when reacting with H plus NH chemical oxidation, loss of hydrogen. The product will be formation takes place in oxidation. Pyrimidine reacting with peracetic acid. Reacting with peracids or peracetic acid. In oxide will be formation takes place.
సార్ గుడ్ ఆఫ్టర్నూన్ సార్.
Tell me.
సార్ స్క్రీన్ సరిగ్గా కనిపించట్లేదు సార్,
Okay,
క్లారిటీ
okay,
లేదు
okay.
సార్. ఇంకోటి సార్, ఎగ్జామ్ ఏవేవి ఇంపార్టెంట్ క్వశ్చన్ ఉంటే మీరు చెప్పేటప్పుడు అలా చెప్పండి సార్, కొంచెం ప్రిపేర్ అవ్వడానికి మాకు బాగుంటుంది.
నేను చెప్తున్నా లాస్ట్కి అయిపోయినాక ఈ టాపిక్స్ ఇంపార్టెంట్ చెప్తున్నా కదమ్మా. అది అంటే ఆ, చెప్ప చెప్పడం అంటే కష్టం అమ్మా ఇంపార్టెంట్ అని. మాక్సిమం మనం గెస్ చేయలేం కానీ కొద్ది
సార్
వరకు ఇంపార్టెంట్
సార్
చెప్తున్నా
మాకు
మీకు.
అన్ని చదవాలంటే ప్రాబ్లం సార్. సార్
కరెక్టే అమ్మా. హెట్రోసైక్లిక్ కష్టంలే కానీ నేను కొన్ని అక్కడక్కడ ఇంపార్టెంట్ చెప్తున్నా. నేను చెప్పిన ఇది ఇంపార్టెంట్, దిస్ ఇస్ ది ఇంపార్టెంట్ వన్, దిస్ టూ
సార్ కొంచెం
ఇంపార్టెంట్.
మా గ్రూప్ లో కూడా ఇది టెలిగ్రామ్ లో పెట్టండి సార్, కొంచెం ప్లీజ్ రిక్వెస్ట్ మా తరపు నుంచి.
టెలిగ్రామ్ అంటే నాకు లేదు టెలిగ్రామ్.
సార్ సార్ సార్, ఇది కోటేశ్వర సార్ కి చెప్తే సార్ పెడతారు సార్, కొంచెం ప్లీజ్ రిక్వెస్ట్ సార్.
ఓకే
అన్ని
సార్
సింథసిస్ లో ఉన్నాయి, గుర్తు పెట్టే కూడా కష్టం అవుతుంది సార్, అందుకని.
చెప్పడం కూడా కష్టమే. ఎందుకంటే ఇంత పెద్ద టాపిక్ ని యూనిట్ ని 1 hour అంటే కష్టం అవుతుంది అది. సో చూద్దాం.
అందుకే కొంచెం ఇంపార్టెంట్ బేస్ అని చెప్తే కనీసం అవన్నీ చదువుకుంటాం కదా సార్, అందుకని.
ఓకే ఓకే.
ఓకే సార్, థ్యాంక్
నెక్స్ట్, రియాక్షన్స్ ఆఫ్ మిథైల్ గ్రూప్. Reactions of methyl group. So methyl group at methyl group at methyl group at C2 is more reactive than C4 than C6. C2 is more reactive than C4 than C6 positions. When if methyl at C2 position when reacting with base followed by aldehyde, then chalcones will be formation takes place. Chalcones will be formation takes place. Elimination of water molecule. Next one is dimorph rearrangement. This dimorph rearrangement is when one alkyl to amino pyrimidine, one alkyl to amino pyrimidine. This one alkyl to amino pyrimidine, when reacting with water molecule, attack it here, then by bond shifting to another carbon, then the product is O minus OH NR double bond NH N. It is involves in the ring opening takes place. It is undergoes here. It is, I am writing like this, see here. NH NHR. It is involves in addition of lone pair of electrons attack here by bond to shifting there. Then the product is OH R NHR double bond hydrogen. This hydrogen involves in loss of water molecule. Then the product is NHR and the product will be formation takes place. This product will be formation takes place. Next one is pyrazine. This is a pyrazine. When pyrazine alpha amino carbonyl compounds, 2 moles of alpha amino carbonyl compounds when reacting with base, it is involves in loss of 2 moles of water molecule. Again, in presence of air, then elimination of hydrogen, pyrazine will be formation takes place. Pyrazine will be formation takes place. First method. Second method is 1,2 dicarbonyl compounds reacting with diamines. 1,2 diamines. 1,2 diamines in presence of base. Or now it is involves again. Now it is involves in presence of air, loss of hydrogen, pyrazine will be formation takes place. Next reactions. Pyrazines are weak base. Pyrazines undergo diprotonation in presence of strong acids and N-oxides. Pyrazines are converted into mono and di-N-oxides by peracids, trifluoroacetic acid. Pyrazine reacting with hydrogen peroxide in presence of acetic acid. One of the nitrogen undergo an oxidation will be formation takes place. Trifluoroacetic acid, trifluoroperoxytic acid, strong acid. So therefore, 2 nitrogens undergo an oxidation will be takes place. Here, weak acid it undergo one oxidation undergo oxidation. An oxidation takes place. Electrophilic substitution reactions. Electrophilic substitution reactions when pyrazine reacting with chlorine in CCl4 40 degrees Celsius. Chlorination will be takes place. Nucleophilic displacement reaction. Nucleophilic displacement reactions when 2-chloropyrazine when reacting with ammonia, loss of HCl, NH2 when reacting with sodium alkoxide. This product will be formation takes place. When 2-fluoropyridazine reacting with sodium azide, 2-fluoropyridine reacting with sodium azide, sodium fluoride will be elimination takes place. Then the product is N negative. It is involves in the ring formation. The ring will be formation takes place. Reaction with organo-grignol reagents, organometallic reagents. Reaction with metallic reagents. Reaction with organometallic reagents when pyridazine reacting with phenyl lithium attack at second position. Phenyl lithium when it is reaction with the water molecule, loss of lithium hydroxide will be elimination takes place. Then hydrogen is replaced. Hydrogen is replaced. Phenyl in presence of air, loss of nitrogen gas. Then phenyl will be formation takes place. Next one is methyl group on pyrazine ring carbon are reactive when pyrazine attached to methyl group. When pyrazine attached to methyl group, this methyl group reacting with sodamide, then B subtract the proton from methyl group CH2 minus. This is reacting with the different electrophilics. This involves in elimination of halogen. Then the product is CH2R and reacting with aldehyde. CH2OH or will be formation takes place. This is the pyrazine. So next we are going to discuss unit 14, synthesis of pyrimidine, purine and xanthine bases.
సార్
Synthesis of
పేపర్ ఒకసారి టర్న్ చేయరా?
so everything is present in your notes only, these reactions, but I am explaining your mechanism.
ఓకే సార్.
Next one is unit 14, synthesis of pyrimidine, purine, xanthine bases. Xanthine bases. So in this case here, we are discussing compounds like in your notes like this here. Uracil, thiamine, cytosine, 5-methyl cytosine, and 5-hydroxymethyl cytosine, and adenine, guanine. These compounds are there. We are discussing synthesis one by one. And xanthine, caffeine, theobromine, theophylline. Okay, here these three are very very important. Theophylline, theobromine, and caffeine. These three are very very important. And these three important, and these three important. Okay, we are discussing and 6 compounds. So uracil, thiamine, cytosine, and caffeine, theobromine, theophylline. These 6 compounds are important. We are discussing one by one. Okay, these 6 compounds. First, we are discussing uracil. They ask you a synthesis of uracil directly. They are asking you synthesis of uracil, thiamine, or cytosine, like this only. We are discussing one by one. First, we are synthesis of uracil. Synthesis of uracil. Synthesis of uracil. The structure of uracil is this is a uracil, structure of uracil. Now, the synthesis of uracil is from malic acid. This is a malic acid. And this malic acid reacting with urea, NH2, NH2, urea in presence of fuming H2SO4. Then the product is uracil will be formation takes place. Uracil is the formation takes place. Now synthesis of this compound when malic acid reacting with H2SO4. First, it is elimination of water molecule and elimination of carbon monoxide. Then produces C double bond O, CH2, CHO. This is formyl acetic acid. Formyl acetic acid. This formyl acetic acid reacting with urea. Formyl acetic acid reacting with urea, then produces this uracil will be the formation takes place. Uracil will be the formation takes place. Second one is synthesis of thiamine. Thiamine. The structure of thiamine is this is a thiamine. See here. In this case, here methyl is there. Here only hydrogen is there. This hydrogen, if you replace the methyl, is a thiamine.
సార్
Yes, tell me.
సార్ యూరియాసిల్ ఇక్కడ 1 2 3 అని 3 టైప్స్ ఇచ్చారు కదా సార్, ఏదైనా 1 టైప్ రాస్తే సరిపోతుంది సింథసిస్.
అందుకే I'm explaining first one. It is easy, ma. This is easy way. That's why
ఓకే
I'm explaining this one. Okay. They're asking you
ఓకే
explain for 4 marks. I think 4 marks question. They're asking you explain write the synthesis of uracil directly. Okay.
ఓకే సార్, థ్యాంక్ యూ సార్.
When reacting with urea, Then it is reacting with ethyl methaacrylate. Ethyl methaacrylate is the ethyl methaacrate. Okay, it is involves in heating. Then undergo Michael addition. Then followed by elimination of ethanol. Then the product is NH C double bond O methyl, the attached nitrogen here. Now it is involved in bromination in presence of acetic acid. Alpha position of carbonyl compound is more active, therefore bromination at alpha position of carbonyl carbon. Hydrogen C double bond O in presence of pyridine. It is elimination of HBr. Then the product is C double bond O NH C double bond O C double bond and this one. So this is the what is thiamine is product will be formation takes place. Next one is cytosine. Next one is cytosine. In this cytosine, that S-ethyl thiourea, S-ethyl thiourea S-ethyl thiourea when reacting with S-ethyl thiourea reacting with sodium formyl acetic acid. Sodium formyl acetic acid. Sodium formyl acetic acid in presence of heating, elimination of ethanol, elimination of sodium hydroxide, elimination of sodium hydroxide, elimination of ethanol in presence of sodium hydroxide. Then cyclation will be formation takes place. NH double bond SET double bond O. Here hydrogen will be formed. Here hydrogen. Now it is reacting with POCl3. Carbonyl is converted to chlorine and N double bond here S ethyl. It is reacting with ammonia in presence of ethanol. Then the product is NH2 N S ethyl. It is reacting with HBr, then produces cysteine. Cytosine will be product will be formation takes place. Cytosine is the formation takes place. This is a cytosine is the formation takes place. Next one is synthesis of caffeine. Next one is synthesis of caffeine. Synthesis of caffeine by by Trubin method. By Trubin method. When this method, NN dimethyl urea, this NN dimethyl urea reacting with CH2Cl, ester CH2Cl in presence of sodamide base, then product will be C double bond O, here elimination of here N methyl NH2 double bond C double bond O N methyl. It is involves in nitrosoation with HNO2. Here nitroso will be formation. Formation takes place. N methyl double bond O N methyl NO C double bond O. This compound, it is NH2 is there. Now this compound reacting with zinc in acetic acid, zinc in sulfuric acid, NH2. Now it is reacting with formic acid. Then cyclic will be formation takes place. NH, then C double bond N methyl, C double bond O. And when reacting with methyl iodide in presence of base, this hydrogen undergo methylation. C double bond O, here methylation. This is a caffeine. Next one is theobromine. In theobromine, the name is bromine is present, but bromine is not present in structure. In the name, bromine is present, but in the structure, bromine is not present. Okay, here hydrogen, here methyl, C double bond O, N methyl. Okay, in theobromine, at adjacent ring methyl group is present. Adjacent group is present. At adjacent position, methyl group is present. Now, synthesis of this molecule is only monosubstituted 1N-methyl urea reacting with the cyanoestic ester in presence of POCl3. Second one is sodium hydroxide. Second step is sodium hydroxide. Then the product is C double bond O N methyl NH C double bond O NH2. Then reacting with HNO2, N methyl NH2 NO C double bond O NH C double bond O. It is reacting with zinc. In sulfuric acid. Nitroso is converted into nitroamine. NH2 reacting with formic acid. It is involves with methylated sodium hydroxide. This hydrogen involves in methylation takes place. This is a theobromine. Okay, in theobromine, two methyls are adjacent position is present. Next one is theophylline. Next one is theophylline. In this theophylline, N-methyl, N-methyl, NHN. In theophylline, in 5-membered ring, two methyls are present. In 5-membered ring, nitrogens with two methyl rings. Two methyl rings. So when it is reacting with dimethyl urea, NN dimethyl urea, NN dimethyl urea, when this NN dimethyl urea reaction with the same cyanoacetyl ester, cyanoacetoester, the product is N-methyl C double bond O, N-methyl H C double bond O, Cn. It is undergo addition reaction with Na in sodium carbonate for by hydrolysis. N-methyl NH2 C double bond O, N-methyl C double bond O. Now reaction with HNO2, a nitroso will be formation takes place. Nitroso will be formation takes place. Nitroso when reacting with zinc in H2SO4, NH2, N-methyl C double bond O, N-methyl C double bond O. It is reacting with formic acid. So therefore, thiophylline will be formation takes place. These three are important. Thiophylline, thiobromine, caffeine, uracil. Uracil, what is it? Uracil and thiamine, uracil, thiamine, cytosine. These six are very, very important. Okay. Thank you. We are meeting next class.
Okay, sir. Thank you.
Okay.